This video is going to cover the 1.3 warm-up and the 1.1 to 1.3 quiz review. If you haven't already, pause this video to allow for time to complete the warm-up, if you'll do that now. And then once the students are complete with the warm-up, you can hit play to continue. Okay, so let's go through the answers for this warm-up. Number 1 says AD, or segment AD, bisects segment CD at E. If CE is 2.5 inch, find CD. So the first thing we know is that CD is being bisected. This has to be a segment in order to be cut in half. And it's being bisected, which means it's going through the middle by AB. So we don't know the length of AB, but we do know that it has cut CD into two congruent parts. So if CE, which is where this is bisected, if CE is 2.25 inch, and you want to find the length of CD, then I just have to double it. So 2.25 times 2, or 2.25 plus 2.25. You can even convert these into improper fractions if you wanted to. That would be 9/4. So it would be 9/4 plus 9/4, or 9/4 times 2, which is 18/4, which gets reduced to 9/2, or 4.5. You'd get the same thing by adding 2 and 2 and 1/4 and 1/4. You'd get 4.5. Either way, whichever way makes the most sense to you is what you want to do. So 4.5. Number 2 says point M is the midpoint of XY. Find XM. So if this is XY and this is M, this is the midpoint. This means it's in two congruent parts again. So I can say that 2x plus 7 equals 8x minus 23, and then I want to solve that. So you want to subtract the 2x. 7 equals 6x minus 23. Add the 23. 6x equals 30. Divide by 6. And x is 5. But it's not asking for x, it's asking for xm. So you want to take that 5 and you want to plug it back in. So I'd get 2 times 5 plus 7, or 10 plus 7, which is 17. Three says point M is the midpoint of PQ with endpoints P 2, -6, and Q, -8, 0. Find the coordinates of M. So this is our coordinate geometry. We went over that the equation, or the formula for midpoint, would be x1 plus x2 over 2, and then y1 plus y2 over 2. So if this is my x1, y1, x2, y2, I'd get 2 plus 8, or sorry, 2 plus -8 over 2, and -6 plus 0 over 2. So I'd get -6 over 2, -6 over 2, which is -3 and -3. Number 4 was probably the most challenging in this section. It says the midpoint of GH is M, which is 4, -1. One endpoint is G, 5, 3. Find the coordinates of H. So this time you don't have both endpoints to try to find the middle. You have one endpoint and one midpoint. So because we know that x1 plus x2 over 2 gives us the x coordinate of our midpoint, and y1 plus y2 over 2 gives us the y coordinate of our midpoint, we can take and plug in what we've got into these equations and then solve. So because M is the midpoint, we're going to make this x1 or xm, and ym. And then G is one of the endpoints, so we'll make that x1, y1. What we're missing is the x2 and the y2. So now we're going to plug in what we've got. x1, which is 5, plus x2, which is what we don't know, over 2, equals the x coordinate of my midpoint, which is 4. And then do the y's. y1, which is 3, plus y2, that's what we don't know, over 2, equals the y coordinate of my vertex, which is -1. So then I would solve these equations by multiplying 2 on both sides. They're going to cancel here. 5 plus x2 equals 8. Subtract the 5, and x2 is 3. Same steps on the right here. Multiply both sides by 2 to get rid of the denominator. 3 plus y2 would be negative 2. Subtract the 3, and y2 is negative 5. So the coordinates of h, or our other endpoint, is 3, negative 5. Okay, last one says to find the distance between the swing and the sandbox in his backyard. Darren made a graph and found the coordinates of the swing to be 7, 2 and the coordinates of the sandbox to be negative 3, 8. Find the distance between the swing and the sandbox to the nearest tenth of a unit. Now you can go through the process of actually mapping these out, but really what they're giving you here is 2 coordinates and it's asking for the distance. We also went over what the distance formula was, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. So these two are our endpoints, and it doesn't matter which ones we make 2s or 1s as long as you're consistent. So I'm going to plug those in, x2 being 7 minus x1, which would be a negative 3 squared, plus y2, which is 2, minus y1, which is 8 squared. Now I'm going to simplify underneath, so minus and negative becomes positive, and I get the square root of 10 squared plus negative 6 squared, square root of 100 plus 36, square root of 136. Now we're going to break this down to see if we can simplify this. So 2 goes into this 68 times. 2 goes into 68 34 times. 2 goes into 34 17 times. And then we've hit all prime numbers. So now for each pair of numbers, that one number is going to go the outside of the radical. And then whatever doesn't have a pair is going to stay underneath. So because there's 2 2's, I'm going to bring a 2 to the outside of the radical. What's left is 2 and 17. So I'm going to multiply those together and keep them underneath the square root. And there's the distance from the swing to the sandbox. Now this is to the nearest tenth of a unit, so you can actually approximate this, okay? This is the most accurate answer, and when you're doing the quiz, you'll leave it like that. But let's say you wanted to approximate. If you came back up to 136, and you said 136 is not a perfect square, but I know it's in between 2 perfect squares. I know it's in between 121 and 12 squared, which is 144. So this is 11 squared, this is 12 squared. And it's probably about midway between. It's 15 more than 21, and it's 8 less than 144. So it's a little bit closer to 144, which means when we approximate this, we'll say it's approximately, let's say 11.7 or 11.8 feet. But again, this is, if it's on the quiz, it's actually going to, I would rather you keep it exact, which is that 2 root 34, just because this is a word problem that said to nearest, round to the nearest tenth, would you have done that? Okay, so now we're going to talk about your quiz. Your quiz tomorrow is on 1.1 to 1.3. What I want you to do is take notes just on what I'm writing, add them onto your warm-up, and then at the end of the video, you'll turn in your warm-up and your notes to the quiz review all in one document. There's an assignment on Canvas to submit that to. All right, so let's talk quiz. So 1.1 was a lot of vocabulary. So you want to know the definitions in 1.1 to points, line, segment, ray, plane, space, collinear versus non-collinear, coplanar versus non-coplanar, intersection, opposite rays. So a point is, remember, the simplest form in geometry. It's labeled by a capital letter. It is, it's made, every object in geometry is made up of points. A line is unending. It has, it has no length because you can't measure it. It points forever in two directions. A segment is a portion of your line, so it stops. It has two endpoints. You can measure a segment. A ray has one endpoint and one arrow, so again, you can't measure it. It would point forever in one direction. And remember that rays matter what order you write the name, whereas a segment, it doesn't matter. These are the same. And a line, it doesn't matter. Remember, a line can also be named with a lowercase italicized letter in addition to 2 points. A plane is it's represented by a tabletop or a rectangle, but remember, these go on forever without ending. So again, you can't measure a plane. A plane has no thickness, it has no edges, but we do use like the floor, for example, as a representation of a plane, but technically that floor would have to continue on in all directions. And then space is a collection of all points. Collinear means that three collinear points would lie on the same line. So something like A, B, those are collinear. As soon as I throw in something that's not on the same line, I can say A, B, and C are non-collinear. Coplanar means they all lie on the same plane, so all three of these would be coplanar. If they are collinear, they're also coplanar. Intersection is where two objects meet. So this could be two lines meet at a point, two line segments, two rays that all meet at a point. A line and a plane meet at a point. Two planes meet at a line. So you want to be able to like picture what those would look like and figure out what the intersection would look like. And then opposite rays are two rays that share the same endpoint but point in opposite directions. So something like ray CA and ray AB would be opposite rays. They form a straight line. .2 is some more definitions again, but we got introduced to some postulates, and we also started to do a little bit of arithmetic with the lengths of segments. So we talked about the length of a segment. If it's on a number line, it was marked off like A, B, C, D, E, and then let's say they were all, each one unit, you could find the lengths of these segments. If I said A, B, this was 1, 1, 1, 1. This would be A, C would be 3, 1, 2. Sorry, would be 2 units, something like that. This is where we got introduced to coordinates. So if this is 1, 2, 3, 4, 5, the ruler postulate which told us that every point on a line can be paired with a coordinate. So you've got a letter that also gets paired with a number. That's what that ruler postulate told us. Okay, and then we talked about something that you're going to use a lot, which is the segment addition postulate. Which basically just says that if you take a segment, break it down into its parts, and you add it back together, you get the whole. So if B lies between, not necessarily halfway between, just between A and C, then AB plus BC equals AC. So you've got your segment, somewhere between A and C lies B. Again, not necessarily halfway between, but if I know this and this, I can add them together to get the whole. And then the last thing that we talked about in section 1-2, which is also super important, is what does congruent mean? And remember, congruent means the same size and shape. So two segments that are congruent would have the same length. 1, 3 is the midpoint and distance formulas. So we talked about, again, definitions. What is a midpoint? Which is the point halfway between two endpoints. We talked about a bisector, which could be a point, line, ray, segment, or plane that divides a segment into two equal parts. So while a midpoint is obviously just a point, if this is A and this is B and this is C, and these are congruent, then I can say that C is the midpoint. But I can also put a ray here and say that CD, ray CD, bisects AB. So a bisector can be a point, it can be a line, it could be a plane, it could be a ray, it could be a line segment. We talked about the midpoint formula, which again is your x1 plus x2 over 2, and then y1 plus y2 over 2. And you had two types of problems, one where you were given the endpoints and you had to find the midpoint, and the other where you were giving one midpoint, or one endpoint and the midpoint, which was like number 4 from the warm-up, and you had to find the missing one. And then the last thing we talked about was the distance formula. x2 minus x1 squared plus y2 minus y1 squared. So again, you want to take all the notes that you just wrote in addition to your warm-up on the same note, and you want to submit it to the assignment on Canvas that says classwork 1.3 warm-up and quiz review. And then you want to spend the remaining part of today's class working on your quiz review. So it's not graded because the answers are already on there. It says 1.1 to 1.3 quiz review. The answers are on the worksheets, so my advice is work through them and then check them. And then if you still have questions when we come into class tomorrow, we'll spend the first part of the class going over the quiz review, and then you'll take your quiz the second part of the quiz. The second part of your class period. I hope everybody has a great day. If you need any extra help, I'll actually be in my room after school today, after the transfer orientation is over. If not, I'll be able to answer questions tomorrow in class. Good luck on studying and have a great day.